Okay, so whenever you have similar triangles, you'll be able to find missing measures in them because it says their corresponding angles are congruent. I'm going to start by this. I don't know how this works. Their corresponding sides are proportional. So that means that their sides are growing at the same rate. So if I have 3 out of 4 sides on 2 different similar triangles, that means I can set up a proportion because the sides grow proportionally, and I can solve that for a missing side. So here's an example of what the problems will look like. While playing tennis, Matt is 12 meters from the net, which is 9/10 of a meter high. He needs to hit the ball so that it just clears the net and lands 6 meters beyond the base of the net. What is the height? No. At what height should Matt hit the tennis ball? It tells me both triangles contain angle A, so that's this one over here in this far left corner. And they both contain a right angle. So triangle ABC and triangle ADE are similar, okay? So I have this overall picture. I have a large triangle, and then within it I have this small triangle. They said that they're similar because, remember, to be similar it just has to have 2 pairs of congruent angles that you can prove are congruent. It's easy to prove that this angle right here where the B is and the D, they're congruent because they both have that right angle symbol that we know that means 90 degrees. We also are for sure that angle A down here, the smallest angle, is going to be congruent for both of them because it's in the same spot. And the little triangle and the big triangle end up right there. So it does have 2 pairs of congruent angles, therefore this one at the top has to be equal. So since we can tell that they are similar, I can set up a proportion because the side lengths are proportional for similar triangles. On my picture, I would go ahead and put either like an X or a question mark about the part that they were asking. They were saying, how high does he have to hit the ball right here to be able to just clear that net and go 6 meters on the other side? So they labeled the height of the net for me that they gave me in the description, 9/10 of a meter. I know that it wants to go 6 meters on the other side, and then they're letting me, they also told me Matt's 12 meters from the net, so they've already labeled that for me. The best thing to do whenever your picture, your shape is like combined into the other one is going to be to draw them separate so it's easier to see and set up your proportion. So I have this little triangle. You want to bring its dimensions with it, 6 meters and 9/10 of a meter. And then I have that large triangle. And here's where y'all will need to be careful. This is where the most mistakes happen. You know that we're missing this height of the big triangle. Now to get the bottom length of this big triangle, it's spanning all the way from here to here. Some kids would mess up and they would want to put 12 because they see that 12 and then bring it right down. But this big triangle, it was 12 meters from the net, but then the big triangle continues to the other side. He wanted to go 6 meters on the other side. So I'm going to have to add the 6 plus 12 to get at the base of the large triangle is 18 meters. Now, once you've drawn your large and your small, I would label them small and large. Whenever you set up your proportion, there's so many different ways for y'all to set it up. But the most important thing is to use labels and to be consistent. So, my favorite way is always small over large. If y'all aren't using word labels, you're not as likely to set it up correctly. Now, you know a proportion is made up of two equal ratios, so I got to put my bar equals bar. Then you want to decide what you want to use for the first ratio. I always like to pick one that's filled in for both of the triangles, so notice how they both have the base. So I'll use a word label. It's going to be base for this first ratio, and then over here it's going to be about the height. So once I've got word labels set up everywhere, then that tells me exactly what to put right here. I want to get the small base. So small means small triangle, had a base of 6. The large base is what goes right here, and that was 18. So move to the other side. I'm at the top, so I check that word label. Small height was 9/10 of a meter. The large height is the one that I don't know. Okay, so once you've used your word labels and you've got your proportion all set up, you have to multiply the numbers that were diagonal. So I'm going to be working 18 times 9/10. Once you've got that answer, then you're going to divide it by the number that was left over. And in this case, 6 I haven't used yet. Okay, so let's see. 18 times 0.9 gave me a 16.2. So I'm going to divide that by 6 to get 2 7/10. Remember, for word problems, it's going to have some type of meaning to its answer. So it wasn't just 2 7/10, it's 2 7 meter, because they were asking me how high he had to hit the ball. Okay, so let me box in my answer. Okay, so it says, what if? Suppose you set up a proportion so that each ratio compares parts of one triangle as shown below. Show that this proportion leads to the same value of h as in example 2. Okay, so notice before whenever I set it up, I said small to large, but now they're wanting me to say height to base. So I'm going to label height to base. They had used BC. So that's going to be the height of the small one. And then DE was the height of the large. Okay. Remember how I said like there's lots of different ways for you to set up that proportion? I just favor small to large because it's easier for my brain to start that way. It's okay if your brain's not like mine and you would rather do height to base every time. So on the picture, the small height was the height of the net, and the small base was 6 meters. The large height is the one that we didn't know, and the large base was, we had to add that together to get 18. Okay, now remember for solving a proportion, I said that you had to start by multiplying the ones that are diagonal. So this time, even though it doesn't look exactly like the same order as this, notice that the diagonal was 18 9/10. 18 9/10, just like this one. And then the number left over that I have to divide by is still a 6. So whenever I multiply, that would still be 16.2 divided by 6 is 2 7/10 of a meter. So it's up to you whenever you work on your own. If you want to start with small to large, whenever you go to start grabbing numbers, or if you want to start with height to base. Either way will work and give you the right answer.